going to throw in a basic trig lesson on solving triangles that you can look at in the middle of your vectors. So you can go about adding vectors without any problems. This is really higher level maths, but I'm throwing it in here for the applied math students. So you don't make any silly mistakes when it comes to solving triangles. It's very easy to make mistakes solving triangles when you use something called the sign rule, which is what we call ambiguous. I'll explain what that means in a few minutes. But there's a triangle there. And a triangle, as you know, has three sides, three S's, and it's got three angles, three A's. So the angles are called A, B, C, and the sides are little letters A, B, C. Side A is directly opposite angle A, side B directly opposite angle B, and side C directly opposite angle C. Now, to solve triangles, it means they'll give you some information. They might give you some sides or some angles, and you have to find missing sides and missing angles. There's two rules we're going to use for these non-right angle triangles. We're going to use the cosine rule, and we're going to use the sine rule. Now, how do I know which one to use? Well, you can do trial and error if you want, but when we do vectors, I'll normally use the cosine rule for what I call an SAS. In other words, I'm given two sides, S and S, at an angle, but look where I put the angle. I put it in between the two sides. So we call that an included angle. So if you look at an example that I'm going to do here in a minute, that's going to be an SAS. They're asking me to find X. Well, you've got the lengths of two sides, 4 and 6, and the angle in between them. So therefore, that's an SAS, and that's screaming at me, use the cosine rule. Now, here's the formula for the cosine rule. It's in your table book. A squared equals B squared plus C squared minus 2BC cos A. There's other versions of it as well. You could have B squared is equal to and C squared is equal to. But you know, I don't really want you to learn the formula. I want you to feel the cosine rule in your bones. So this is how I would do it. A squared is equal to B squared plus C squared minus 2BC, the cos of the included angle A. Or if, let's say, it was B squared. I do it by feel. B squared is A squared plus C squared minus 2AC cos B. Or if they asked me to find C, I'd say C squared equals A squared plus B squared minus 2AB cos of C, the included angle. See how you feel it? Don't be writing down all these letters, A is equal to B is equal to on your triangle. So here I go. In this particular example, they want me to find X. It's SAS cosine rule. So I say X squared is equal to 4 squared plus 6 squared minus 2 times 4 times 6 by the cos of the included angle 30 degrees. So it's 4 squared plus 6 squared minus 2 times 4 by 6 by the cos of 30 degrees. Therefore, X is going to be the square root of all of that. So it's the square root of, if you want to do a little bit of tidying up, you can do it. The square root of 16 plus 36 minus 48 cos 30 degrees. So let me put that into my calculator. The cosine rule is what we say, it's non-ambiguous. You don't have to worry about getting two answers. Ambiguous means there's two possible meanings or answers. Non-ambiguous means there's only one possible answer, so I don't have to worry about the cosine rule. It's the square root of 16 plus 36 minus 48 times cos 30 degrees. And I get an answer of, let's say, 3.2. There's no unit, so it's just 3.2 to 1 decimal place. That's the cosine rule. The sine rule is a bit trickier in the sense that you've always got to check out for two answers. It's ambiguous. When do I use the sine rule normally when I'm doing vectors? Well, when they give you two sides as well at an angle, but the important difference is, I'm going to write it down as SSA. You see that A? It's not between the two S's. So it's what we call a non-included angle. So if you're given two sides and an angle that's not between the two sides, then you will use the sine rule. Here it is in your table book. A over sine A, side A over the sine of its angle is equal to B over the sine of its angle is equal to C over the sine of its angle. It's a three-part formula, but you'll only ever use two parts when you do a question. You can also have it the other way around. You could have sine A over A equals sine B over B, sine C over C, whatever way you want to do it. But I want you to feel it. Feel it. A over the sine of its angle is equal to another side like C over the sine of its angle. So SSA is when we use the sine rule. Let me have a look at an example of the sine rule. So there's my triangle. They want me to find the angle theta. Well, first of all, I recognize it as, yes, I'm given two sides at an angle that's not included. In other words, if it was an included angle, it would be in there between the 4 and the 6. So therefore, it's an SSA. I'm looking for theta. I'm looking for sine theta. I'm actually going to put the signs on top. So I go sine theta divided by the length of its side, which is directly opposite, 4, is equal to the sine of 30 divided by its side, which is 6. Multiply both sides by 4, slide the 4 up. So I get sine theta is equal to 4 times sine 30 divided by 6. I want the angle theta. So theta is the inverse sine of 4 sine 30 divided by 6. So put that into my calculator. Make sure your calculator's in degree mode. So shift sine fraction 4 sine 30 close bracket divided by 6, close the big bracket, and I get, say, 1 decimal place, I get 19.5 degrees. Now, there's two possible answers every time you use sine. Sine is ambiguous, and you should always check for the second answer. Sometimes you need it, sometimes you don't. Sometimes there is no second answer, but always check. How do I find the second answer? I take that angle away from 180 degrees. The reasons we do that is explained in more details in your maths courses. So I get 160.5 degrees. There are two possible answers. But hang on, you know that the three angles of a triangle add up to 180. You see that angle in there? We told that angle 30 degrees is in that triangle. Well, if I added 160.5 degrees to 30, I get 190.5 degrees. That goes beyond the 190, so that's not possible. So therefore, we can't actually have that. So my answer is 19.5 degrees. That's the only answer that we actually have. So that's your basic trig. Know that before we start adding vectors in the applied maths.